Okay, so now that we've done our correlations, it's important to follow these up with scatter plots. And really, whether or not you do your graphs or your numerics first, it really doesn't matter, but they all need to be done. So if we're going to be looking at numeric by numeric pairs of variables, the appropriate bivariate graphical output is a scatter plot. So we'll have a look at one of these. We're going to look at 3 scatter plots in particular, and then I'm going to challenge you to go away and do the rest on your own because there's lots of them. Um, but every scatter plot, you want to comment on 7 different features. So the first is going to be the direction. And so what that means is, well, maybe it would be better if I actually show you a scatter plot first and we can talk about these things. So let's look at the first scatter plot. So this is between shame and cultural discrepancy, just for fun. So the syntax, we first say two-way and then scatter. We have to say two-way scatter because there's lots of different kinds of scatter plots. We're looking at two-way scatters. And then I put my 2 variables, in this case, shame and cultural discrepancy. I then need 2 vertical lines. Now these vertical lines do not have a space between them. And then I write lfit, which means fit the line of best fit. And then I write shame and cultural discrepancy again. I have to write these 2 because if I write another pair of variables here instead, it'll fit the line of best fit for that other pair of variables. That's kind of handy if you want to like layer things, but we don't. So two-way scatter variables, 2 vertical lines, lfit the same variables again. Let's run this. Here's the graph that we get. So we have 7 features that we want to look for here. The first one is direction. So what we can see here is a bunch of dots. Each dot represents a person. So for example, this is a person. This person had 0 on cultural ideal, but had approximately 19 on shame. If we look at this person here, they had approximately 3 on culture and approximately 21, negative 21, negative 22. Actually, no, sorry, that would be more like negative 18. I apologize. Negative 18 on shame. So each person has a score on culture and a score on shame, and we're simply plotting those out, and you get these lovely distributions. So the first thing we're going to look for is direction, and so this is about this line of best fit. Is it in a positive or a negative direction? Is it in no direction at all? And in this case, we can see that as cultural scores go up, so as we go this way, as cultural scores increase, shame scores are also increasing, and this produces a line that goes up towards the right-hand side. So we call this a positive relationship. So this is a positive direction. If it went if it went down towards the right, it would be a negative direction, and if it was horizontal, we'd say there's no direction at all. The next criteria is whether or not it's a monotonic distribution or a monotonic graph. So monotonic means that there is only one direction in the data points. So you can't really tell monotonic from a line of best fit. It gives you an indication. In this case, it looks perfectly fine. The line of best fit is actually a better indicator of linearity. So we'll talk about monotonic and linear together. So linearity means that you have a single direction that always goes at the same extent. So it is always going up by the same amount or the same magnitude. And so here we can see this. So a straight line has a single direction with the same magnitude. On the other hand, though, if I had a monotonic distribution that was not linear, my distribution, my line of best fit, could actually be curvy. Now, lfit is a straight line, it will only fit a linear line. But if my data actually suggests, my data would kind of look like this if it did. If my data suggested that actually a curvy line is better, then what that means is the magnitude of my line is changing. So the extent that my line is here is actually weaker than the section here, which is weaker than the section here, which is weaker than the section here. So as I'm going up, my line is actually becoming steeper and steeper. Now the key thing that makes this monotonic, though, is that it is always in a positive direction. It's just getting more and more positive. Now, technically speaking, if my positive relationship wave, so it got a little bit stronger here, but then it got weaker there, and then it got stronger, and then it got weaker, because it's still all moving in the same direction, it's still monotonic. But this isn't linear. Linear requires it to be a straight line. So if we had the example before like this, with all my data points looking like this, if I fit a line of best fit, my line of best fit's actually going to do that. And so what that means is that if I sort of draw boundaries around my data points, you can actually see that my line of best fit isn't going through many of my data points at all. It's going through sort of this section and that section, but really it's missing here, it's missing here, it's missing up here. So it's possible to have a monotonic relationship that's not linear, and it's possible, but it is not possible to have a linear relationship that is not monotonic. So the rule of thumb: if you have a linear relationship, then you have a monotonic relationship. But just because you have a monotonic relationship doesn't necessarily mean that you have a linear one. So linearity is a special case of a monotonic relationship. So if we go back to our graph, we can see that it is in fact monotonic and it is also linear. Strength. Now, this is a little bit difficult. You kind of have to eyeball strength. And we're talking about strength being weak, moderate, or strong, so using the same terminology as correlations. Here, I would say this is a relatively moderate relationship, weak to moderate probably even. And what I'm basing this off is the angle of the line and how close the points are to that line. So if the relationship was strong, oh, that's black. What I would actually expect is an almost perfectly straight line on the diagonal, with my dots being very, very, very close to it. That would be a strong relationship. A weak relationship, I would probably have an almost non-horizontal, a non-diagonal line, with my dots sort of all over the place. However, let's say I had a combination of the two. Perfectly diagonal with my dots all over the place, I would still probably call this weak, because really, even though that line is really, really, really strong, it's really not going through many of those dots at all. So it is a bit hard to sort of eyeball and go, is it strong, is it moderate, is it weak? Take your best bet, take your best stab at the dark. Generally speaking, I like to sit on the fence, so I would say this is weak to moderate. And I like to sit on the fence because then you're sort of covering your bases with 2 to 3 things. And doing that's perfectly fine unless you're at the extremes. So if it's really, really weak to no relationship, you can't call it weak to moderate. And if it's exceptionally strong, you can't call it moderate strong. But pretty much anything else, you can say weak, moderate, moderate, strong, and generally you'll get away with it. We also want to talk about the correlation because that helps us to inform the strength. So if we go back to the relationship between shame and cultural discrepancy and shame, we can see that it is in fact a moderately strength relationship. Okay, the next 2 things we're going to look at are outliers and gaps. There are no obvious outliers here. So this guy down here is not an outlier, this guy up here is not an outlier, because they really do look like they're part of the distribution. Really, if there was an outlier, it'd be someone down here, someone up there, and generally you can tell they're an outlier because the line of best fit won't follow the bulk of the data. So here there's no outliers. And finally, then we want to look for gaps. Now, gaps don't mean, oh look, there's a gap here, that must be a gap. That's not what a gap is. A gap represents a massive gapping of space that actually produces clouds of points. So, let's say I had some points down here, a massive gap, and then some points up here. Okay, now if I fit my line of best fit, it's going to go like this and suggest a probably strong relationship. But what these gaps generally represent is something very similar to a bimodal distribution, where I said it's probably 2 overlapping distributions with some variable underlying it, maybe gender. Generally, that's the same here. If you've got 2 clouds of points, it's probably the case that each of these are separate distributions, and when I put lines through them, there's absolutely nothing going on. So we don't want clouds because that suggests that there's something else going on. We don't want gaps. And so here, this is the gap. It's a substantial gap creating clouds of points. Here, this is not a substantial gap. Okay, so if we move on to the next one, I'll do this much quicker. So this is self-esteem and internalization. I can see that there is a negative relationship. It's in a monotonic direction. It looks relatively linear, so I'd be okay with this. It's linear enough. The strength really does look like it's weak to moderate, probably more on the weekend. And if we look at the correlation between RSC, self-esteem, and internalization, we can see that it is just passing that cutoff to go moderate. So again, when I said weak to moderate, probably more on the weekend, so that really does confirm my suspicions. Outliers, look, these two are probably outliers here, particularly this guy. So we'd say they're potential outliers and leave it at that. There are no gaps. Okay, and then finally, looking here, this looks like there's absolutely nothing going on. There might be a little bit of a positive relationship, but really that's about as horizontal gets. If it's horizontal, then by definition it has to be monotonic and linear, because horizontal is a straight line. In terms of the strength, you could say it's weak, but there's no direction, which really means there's no relationship. So it's very, very, very weak. And the correlation will be near zero. And if I look at the relationship between trait internalization and negative affect, the Pearson's R is basically 0.08. It's very non-significant. There's nothing going on. And our graph confirms that. Moving on, outliers. He looks like an outlier, but really probably isn't. Like if you look at this distribution, it's just the whole board is covered in points. So I suspect that he's probably not actually an outlier. And then finally, gaps. There are no gaps here. This looks perfectly fine. Okay, cool. That should say me, not Maya.